Hello all, good morning. This is Dr. S. Subbalakshmi, an assistant professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Multiple Integrals, and now we are on to finding the area and volume using multiple integrals. In the previous class, we have seen problems on a problem on finding the area of a given curve, and now also we are going to see a problem or two or more problems on the same concept. For better understanding, we will have two more problems to learn. Now, your problem is double integral over 0 to 1 x squared plus y squared into dx dy. As discussed, the inner limit will be for x and the outer limit will be for y. Since we have got only numerical values in the limits, we will be applying like this way. Now, what is our I? I is the given integral. What is that? Integral 0 to 1, integral 0 to 1 x squared plus y squared into dx dy, which is equal to, we can just integrate with respect to the variable x first of all. So we will keep y as constant. So what will you get here? X squared, on integrating it, you will have x cubed by 3 on applying the x power n formula. And what will be the constant integration? It will be y square into x. Since y square is a constant here, you will have an x here. And within the limit 0 to 1. Now what will we do here? We will just apply the upper limit and the lower limit. Upper limit is 1 and the lower limit is 0. Upper limit 1 will be applied for this x and this x. So you will have got 1 by 3 plus 1 by y squared. And lower limit 0 will be applied for this x and this x, so that the limiting term will be 0. Now these things will not be there. Now you have got only this integral, integral 0 to 1, 1 by 3 plus y squared into dy. This is your existing term as of now. Integral 0 to 1, integral 0 to 1, 1 by 3 plus y squared into dy. What is this? How we will integrate it? We will just integrate it using a single variable term. 1 by 3y plus y squared will be, on integrating, you will have 2 plus 1 divided by 2 plus 1. So it will be within the limits 1 to 0. Within the limits 1 to 0 plus the constant c. And we will just apply the upper limit and the lower limit here. We will just apply the upper limit 1 and lower limit here as discussed earlier. So you will have 2 by 3 as the value. Now what you have got, what you have inferred, what we have result here, we have resulted that the area of the given curve is 2 by 3 square units or so. Now since this is double integral will correspond to an area, so it will be measured in the squaring units. If we are considering triple integrals, it will be for the volumes, and therefore it will be for cubic units. The units will be like regarding the cubic units. Now we have one more problem regarding this double integration, and before that we will have a formula here. Integral x into e power x dx is equal to x into, which can be applied using integral u dv formula. We have already come across this formula earlier in our lower school grades. Integral u dv is equal to uv minus integral v du. uv minus integral v du. This is our formula. Using this formula, we have expanded and got this answer. Now, what is our integral x into e power x dx? We have just taken u to be x, u to be x, and dv to be e power x dx. What are the things you need? You are in need of u, v, and du. Integral v du. You are in need of u, v first of all. So you have got u and you are about to find v. You have got u and about to find v. So what is u? U is x. And differentiating, you have du by dx. Here you are differentiating and here you are integrating. Here you are differentiating and here you are integrating. So differentiating you will have du by dx is equal to 1. Therefore you have du is equal to dx. We are just interchanging the variable for x and y to u and v. And what is dv? dv is e power x into dx. On integrating e power x, you will have e power x alone. Therefore on integrating dv, you will have v alone, as integration and differentiation are complement to each other. We will be cancelling out both the terms and we will have remaining term to be v alone. V is equal to e power x. Now what is our formula? Our formula is integral u dv is equal to uv minus integral v du. This is our formula. This formula have been studied earlier in lower grades. Now on implementing all the found values here, what you will get? This is u is x and u is x, V is e power x minus integral. What is V? V is e power x and du is dx. We have just replaced according to the formula, which is equal to x into e power x minus e power x. On integrating e power x, what you will get? It is e power x alone, which is equal to you will have e power x into x minus 1. So this will be the final answer for this particular problem. Here we have done a single variable integration since to have a knowledge on the UDV formula. And moving on to the next concept, which is called the definite integral, which means integral. In the integral you will have limits. In the integral you will have limits. We will have a single variable concept here. Integral 0 to 1 x squared dx is equal to x cubed by 3. What formula we have used here? We have used x power n formula. Likewise, for the trigonometric functions also we can use the integration as well. These are all for practicing purposes. We will continue this in the next video. Thank you.